Your h should have been up here for -4, 1, 2, 3. Because it says make sure hog is congruent to dog. So that means h to o has to match up d to o, the same lengths. Well, d to o is up to over 1, and h to o is down to over 1, so they're the same length. O to G and O to G better be the same length because it's the same line. O to G, O to G. And finally, G to H and G to D need to be congruent. G to D would be down 2 over 6. Up 2 and over 6 gets us to H. And your triangles should look congruent. I know look isn't the most important part about being congruent because I can draw things that look congruent that aren't because you put values in it. But when you draw your other triangle, it better look congruent to the other one. What I mean is you shouldn't have an H right here. That makes it look weird. And make sure order matters. Order matters in this because every one of these, almost every one of these created a triangle that looked congruent. So if we did 3, 3, 3, 3 would have been here. It would have looked congruent, but the distances would have been wrong. Because if I had the point here, 3, 3, and we had to go from H to O is the same distance as D to O. D to O is that distance. H to O would have been that long distance there, which wouldn't have matched up. So just be careful with your drawings that each one of those letters are the same length. H to O matches up with D to O and all the other ones as well. All right. Let's go over questions from homework first and foremost so we can hopefully get through all those as quickly and painlessly as possible. So which questions do we have from the homework? Yeah.
On number 5. Yeah.
Okay, number 5, yeah.
Yeah. Like it shows 2 like of the kind of tick marks like are congruent. You know?
Mm-hmm.
Yeah, so that means these sides, y, x, and then xz, congruent to BA and AC. But don't those tick marks also mean angle y is congruent to angle z and congruent to angle b?
Yeah, but we don't have any postulates or theorems that state that yet.
Oh, okay.
That was just something we were saying, so I didn't have anything that could prove it. So even though it's one of those things that we know, but we can't prove, so we just have to put no. You are 100% correct. If you would have got to side angle side or something like that, you probably would have been correct, but we don't have the theorems or stuff to support it, so that's why mine says no. On a test, I wouldn't put one like this on there.
Oh, okay.
Okay, one like this wouldn't be on there because, like if you think through it, you probably could get to that they are congruent, but we don't have the theorems and stuff to support it yet. Other questions? Yeah. 15. So the hard part about 15 is probably the toughest one on there because it almost looks like no. Because they have an angle, you could get a vertical angle, and you have a side which looks like angle, angle, side. However, you can go a little further. Look at line NM and line AB. They have 2 congruent angles that are on alternate interior sides of a transversal. So alternate interior angles of your transversal are congruent, so those 2 lines are parallel. So they are parallel. So we could get to the fact that NM is parallel to AB, which means all the angles are congruent as well. So this angle here is congruent to that angle here. And our vertical angles are also congruent. So we can use angle, side, angle. I think my answer key said side, angle, side, but I did have the picture showing angle, side, angle. So I think my answer guy was wrong. It should be angle, side, angle being the correct way. Yeah, Carly.
Side angle side, if you did like since they're sharing line MA.
But they're not sharing line MA. Reflexive would mean that they have the exact same. They look like the same length, right?
Yeah.
But did we ever say that C is the midpoint? No, I would have had to say that C was the midpoint for that to be true. I think that's the hardest part about these because it like looks like they're congruent and it makes sense that they're congruent, but you gotta like think down the proof. What was it? Oh, I'm sorry. Oh, yeah, So this is 90 degrees and that one's 90 degrees, right? And these are alternate interior angles. And we have the alternate interior angle converse that says if they're equal, then these are parallel. So these two lines are parallel to each other. And I can use alternate interior angles to say this angle B is congruent to that angle N. And then I can use vertical angles to say these two are congruent, which would be angle, side, angle, and angle, side, angle. Does that make more sense? That was probably the toughest one on there because you had to go like several levels in. All right, other questions? We just don't have enough time. Ever. All right, 20, we were supposed to show that those two angles, or those two triangles were congruent. And they gave us that PO bisects AB. So since PO bisects AB, before I even look at what the proof is asking me to do, I'm going to explain what that means. PO bisecting AB tells you that AO is congruent to OB. So I'm going to highlight in red what we know right now versus what I have up there. So we know AO and OB are congruent. That's the definition of bisector. It also says that PA is congruent to PB. PA is congruent to PB. Well, we need to prove that these two triangles are congruent. So either I need to use side, angle, side, or side, side, side. Well, I can't find this angle, but I can prove that PO is congruent to PO by the reflexive property, which would be side, side, side. So in fact, I didn't have to do much work until I got to that last. You're usually just missing one thing, either an angle or a side, and you have to decide how I can do that using any method. Yeah?
Does bisects mean that like angle POA is congruent to angle POB, and that AL is the line segment AL is congruent to OB?
Since it says a line is bisecting another line, it doesn't say anything about angles.
Oh.
So it's not an angle bisector, it's just a line.
Oh.
You have to use these as the clue to tell you whether they're talking about angles or lines.
So it's just talking about the lengths.
Yes, just talking about the lengths. That is cutting it right in half, not the angle. Our next one says, given that PO bisects AB. So I'm going to stop there, explain what that means. So PO bisects AB. PO bisects AB, that's given. The definition of bisector says that AO must equal AB. So I put a tick mark here. Then it said that PO, yours says perpendicular, right? Not parallel? Okay, thank God. All right, so I'm going to write that and I'm going to explain what that means. Why is that important? Well, if PO is perpendicular to AB, we can say that POB is congruent to angle POB. It's a definition of perpendicular, because you have two definitions of perpendicular lines. One says that they're congruent, and one says that they equal 90 degrees. You can use either one now. So I have side and angle given to me. Now I just need another side. Well, that's PO through reflexive property. So I use the reflexive property and I have side, angle, side. Does that make more sense now? You sure? Okay. I want to go over number 19 really quick, because 19 has a mistake on it. 19, I skipped a step. I kind of did it in my head. And I saw a lot of you kind of copied that down, which means some of you might be not thinking all the way through. But we need to prove that those two things are congruent. Well, my first step is saying that E is the midpoint of TP and E is the midpoint of MR. The step I skipped, see how I drew these little lines on here? Did I ever say why I can down here? I never did. We should have a step 2 here. This should be 3. This should be 4. That step 2 should explain what midpoint means. Midpoint means it's halfway between, right? So my step 2 should have been like E is the midpoint of TP, so that means TE and EP are congruent. So I should have TP is congruent to EP. And I should also have ME is congruent to ER. And that would be my definition step. Definition of a midpoint. And that would make this 3. That would make that 4. So you should always, anytime there's a statement given in your given, like bisects, midpoint, anything like that, perpendicular, you should explain why it's important. Always explain first, and then worry about the rest later. All right, other questions from the homework? Whew, that was close. Yeah, go ahead. Because you have to do the math. You have to say this has to be 180 degrees.
Oh,
so,
number 11, sorry.
Oh, okay. Number 11, well, so I have a parallel line AC and a parallel line BC, so that means corresponding angles would be congruent. So that makes this angle and this angle congruent because of corresponding angles.
Oh, and then AS is a transversal.
And yeah, AS would be our transversal of it.
Oh, okay.
And we're going to use AS as a transversal for BC and ST as well to say that this angle is congruent to that angle. Okay? Other quick questions? I don't have a ton of time. Guys, if you're struggling on the proof, you have to come see me so we can work together on these. They don't get easier. Don't go, I'll figure it out by the test. Figure it out now, it'll make your life so much easier. The quicker you figure it out, the easier it is. And anyone that's came to see me to work on proofs did really well on proofs on the test, if that's any vote of confidence. All right, that being said, we're going to go into slightly more difficult proofs. And it's not that it's more difficult, they're just longer. They're slightly longer proofs. Now, let me get this out of the way right now. See this little plan here? We're just going to kind of set up how you can write stuff off to the side if you're not good at proofs, so you can get more points for your proof. Just doing a little scratch work off to the side and saying what you're doing. All right, that being said, we'll do some things on the proof, but this is not required. It is not required for you to do a plan on a proof. This is just if you're struggling to think about it. If it's a long proof, you can put notes to yourself. That way, if you mess up here, Mr. Paving can look back over here and say, oh, they had the gist here, they messed it up over here, I can give them more points then. All right, so we have AB and CD bisect each other at M. Here's what I do. Here is what I do when I'm writing a proof. Notice it's like a sentence. It's a sentence that gives us information that hasn't been given to us yet. So I actually stop right here, and in my head I say, what does it mean to bisect? And what does it mean to bisect? Yeah.
To cut something perfectly in half.
Perfectly in half. So if AB and CD bisect each other, in my head I'm looking at, well, each of these segments must be congruent to each other, because that's the definition of bisector. So in fact, before I do anything at all, I'm going to explain what that means and figure out if it's important later. So I'm going to write down my given. My given is AB and CD bisect each other. Bisect at M. And that was my given. Now, before I do anything else, I explain why that's important. And that's important because if M is the midpoint of both of those lines, that makes AM congruent to MB. And it makes DM congruent to MC. So I'm going to go ahead and state that. And DM is congruent to MC. And that is just definition of bisector or bisect. Yeah, man.
Maybe AM is congruent to MB.
Did I do the wrong thing? Oh, yeah, it should be MB. Yep, you're 100% correct. Because I did MC twice, didn't I? MB. And then let's make sure we draw that on our thing. AM is congruent to MB. DM is congruent to MC. Did I even look at that proof yet? No, because every proof follows the same thing. If they give you like a word, explain it in your next step. If they say bisect, explain what bisect means. If they say they're perpendicular, say why that's important. All right, it's always good to just explain that right off the bat, and then you can move on. So I'm going to do that as part of my plan. My plan was from the given, I knew that AM is congruent to MB, and I also knew that DM is congruent to MC. Cool. I want to prove that these two triangles are congruent. To prove that triangles are congruent, we only have three possibilities. We have side, angle, or side, side, side. So what I'm asking for is, well, I'm given two sides. I'm either missing a third side I can find, or I'm missing an angle that's in between them that can help me do one of those theorems. What could I find that I'm missing, Leanne?
Well, for vertical angles,
They'd be congruent. And would that be the angle that's in between those two sides? Yeah. So my plan might be something like use vertical angles. Use vertical angles to show that AMD. I should probably put an angle in there. Is congruent to angle CMB. If that happens, could I be able to prove that those two triangles are congruent? Yeah, what would I use to prove it if I knew those two vertical angles were congruent? Yeah. Oh, we already used it. Let's say we already used it. Can I show those two triangles are congruent?
yeah, because that would be but the lines were parallel.
Lost it?
Yeah.
Had it, then lost it. Grant?
It'd be side, angle, side.
It'd be side, angle, side. We're saying that those two triangles. So our big step is I'm given these things. Only work I had to do is vertical angles. So let's go ahead and put that in motion. So step 3. Step 3 is use those vertical angles. So that is angle AMD is congruent to angle CMB. That is our theorem for our vertical angles. Let's draw that in there. I have my two congruent angles. That sure looks like side, angle, side, right? We have an angle between the two sides. So our step 4 is we're done. Our step 4 is that triangle AMD is congruent to triangle CBM. Did I name that correctly? I hope you didn't write that down, because that is as bad as you can get. That is as bad as you can get. Isabel? BMC. Let's check it. A to M. A to M goes across that one tick mark. B to M, also one tick mark. M to D. M to D goes across 2. M to C goes across 2. And finally, we're left with D to A, C to B. You got it. You got it. And that is because of side, angle, side. So we were given this information. The only work I had to do was come up with that third missing bit of information. And that's typically how we prove triangles are congruent. You just find that third bit of information. Either it's a missing side or an angle that you can see using vertical angles, alternate interior angles, some information, reflexive, and then you have your two triangles are congruent. That should be a triangle, not an angle. All right, you see that next one? Right down here? It has all the same given. It has the exact same picture. The only difference is it asks you to prove something different. All right, and we're going to use the proof above to help finish this. All right, so we're going to take our step 4. We're going to take our step 4, and we're actually going to put it right here. So we're going to carry that step 4 down there, and we'll talk about why. Yeah, Grant.
Do we name it step 4 or step 1?
I'm going to name it step 4 because I'm going to pretend like this is what I wanted to prove the whole time. All right, this is what I wanted to prove the whole time. That is what today's lesson is. You need to prove that two triangles are congruent to actually prove something else using that information. Knowing they're congruent, we're going to use that information. So let's look here. It says that I need to prove that AD is parallel to BC. Let me highlight those really quick. AD and BC, I want to prove that those two things are parallel. The only way to prove two lines are parallel are using our converses. Alternate interior converse, same side in converse, or corresponding angles converse. So as soon as I say, prove two lines are parallel, you are looking for alternate interior angles or corresponding angles. Really are the two main ones that you're looking for. Can anyone see a pair of alternate interior angles that would connect those two things? Aryan?
Angle MAD and angle BC.
Yeah.
CBM.
Gotcha.
Yeah.
So CBM and D, I'm just going to call them A and B.
Yeah.
Because we can, because there's no mix-up. So our hope is we can prove those two things are congruent, right? So let's just put that in our plan. Our plan is prove angle A is congruent to angle B, because then we can use that alternate interior converse. Because once I use that converse, then I can say they're parallel. Well, we know the two triangles are congruent, right? Doesn't that mean all the parts are congruent? By CPCTC, congruent parts of congruent triangles are congruent. By CPCTC, as soon as you prove two triangles are congruent, every part in those triangles are congruent. So the only work we really have to do is use CPCTC. So our step 5 is already laid out for us. That is that angle A is congruent to angle B, and that is by CPCTC. In fact, almost every time you prove two triangles are congruent, if you're not done, your next step is almost always CPCTC, because you proved they're congruent for a reason, and that is to use congruent parts. All right, so we now know that angle A and angle B are congruent. So our sixth step is to say those two things are parallel. So DA is parallel to, I guess I'd use a different order. It doesn't matter. CB. And that is by that alternate interior angle converse. So in a lot of these problems, think backwards. Look at what it means to be parallel. Alternate interior angles are congruent. All right. Then I can use my converses that are parallel. But how do I prove they're congruent? Oh, use CPCTC, so prove that the two triangles are congruent. All right, our next one. Watch this carefully. Watch how much information I pull from this before I actually start working. Step 1, I'm going to read this first sentence. PR bisects angle QPS. I'm going to write that down because that is my given. PR bisects angle QPS. That is my given. Now, without reading anything else, I'm going to explain what that means. Because you better believe if I put it as a given, it's important to you. So you don't have to read the whole thing and decide how you're going to use it. Most of the time, we can go to our step 2 right off the bat and say why that's important. Well, bisect means it cuts that angle right in half. So we are saying PR cuts this angle QPS in half. That means that QPR and RPS are congruent. So that's going to be the first thing I state. I'm going to say angle QPR is congruent to angle RPS. And that is just definition of the bisector. Definition of bisects. Once again, you do not need to read all the way through there. You should just know this word means explain it. Whenever there's words up here, it means explain in the next step. Why is that important? All right, then I see the next thing. It says PQ equals PS, so I'm going to draw it on here. PQ equals PS, and then we'll do our third step is another given step. PQ is congruent to PS. That is also given. All right, so all I did is I read the given, I drew what it meant on here, and I explained what it meant in my proof. That's all I did. All of you should be able to do that. You should all be able to set up a proof just like this because you don't even need to know what's going on. You just need to know how to read, explain, and draw that image on there. All right, so right here took no proof writing skill whatsoever. It's just kind of order. Our next part takes a little bit of skill. We need to prove that Q and S are congruent. Do we have any parallel lines? No. Are Q and S vertical angles? No. All right, those are our two big ways. The third way we can prove things are congruent is proving that the triangles are congruent, and then their parts will be congruent. So that's kind of my checklist. Do I have parallel lines to prove they're parallel? Nope. Are the two things perpendicular? Nope. I don't have any degrees where I could just say, well, it has some 180. Nope. So we have to prove those two triangles are congruent. Yeah.
So it's because PR is like equals PR.
Oh, okay. We just do the next step?
Yeah.
Okay. I'm okay with that. So you're saying PR is congruent to PR, and that is reflexive, right? Now don't say anything else. Can someone explain why CC did that next step? What should be the step after this? I want you all to think right now, why did CC do that step, and what would your next step be? Everyone think that. This is the easiest way to learn proofs, is not to wait for someone to give you an answer. Think on your own. So what I want you to do right now is write your step 5. I want you to write your step 5 on your own. CC is correct, so she's not leading you down the wrong way. Write your step 5 and think about why did she do that. All right, now that we had time to think about it, maybe you wrote it down. Can someone tell me what my step 5 is? Let's go back in black. Who can give me what step 5 is? 4 people? I saw a lot more people writing stuff down. 5 people? Anyone want to just take a shot that hasn't spoke yet? Get it wrong? Who cares? Tori, you want to get it wrong?
Actually,
All right.
so I said angle QPR is equal to, or triangle, sorry.
Oh, okay, okay. Yeah, oh. All right, triangle QPR. Oh, that's RR. R. QPR is congruent to
Angle SPR.
SPR. I agree. You did it in the right order and everything.
Because the side angle side.
Perfect. See? And you didn't even get it wrong. I wanted you to get it wrong and you didn't. Who thinks they know the 6th step? Spell?
That angle Q is congruent to angle S because of
Yep. CPCTC. Kapukataka, if you can't remember CPCTC. Kapukataka is way easier. No, it's in your pink sheet also. It's in your definitions if you ever forget. If you're on a test, you're like, oh, there's a C, there's a P, there's T's in there. C, 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 P, P. C, P, C, T, C. We proved that the two triangles are congruent, so all of their parts are congruent, and it turns out Q is part of the top triangle, and S is part of the triangle, bottom triangle, so we can just say angle Q is congruent to angle S. And my step 6 is just that C, P, C, T, C. All right, one more. I'm going to go through one more. Is it that bad? Not yet. Not until you have to do it on your own. All right, we have WX is congruent to YZ. I have ZW is congruent to XY. I need to prove things are parallel. Let's not worry about proving stuff. Let's first write down our given and draw in our picture what that means to us. So WX is congruent to YZ. WX is congruent to YZ. And we also have that ZW is congruent to XY. ZW is congruent to XY. And everything I drew and wrote is because they gave it to me. All right, let's actually write out the plan here. Let's write out our plan actually on this one. We're going to work backwards. WX needs to be parallel to ZY. That needs to be my last step. We need to have WX being parallel to ZY. The only way I could show that are our converses. Alternate interior converses. And really, it's just either alternate interior or corresponding that are our main ones. So us working backwards, which two angles would I want to prove are congruent to show those two lines are parallel? Which two angles would either be alternate interior angles or corresponding angles in this picture? Oh, yeah?
Angle 2 and angle 1 would be alternate interior angles.
Yeah. Do we all see that? If we look at angle 2 and angle 1, those are alternate interior angles. If I could just prove those two things are congruent, I can say these are parallel by that alternate interior angle converse. So my plan is to show angle 1 and angle 2 are congruent. I guess instead of and, I'll just put angle 1 is congruent to angle 2. I want to do that because then I can use alternate interior. Well, guess what we're going to use to show that? I'm given two triangles. There are parts of the triangles, so all I need to do is CP, C, T, C. I want to show that two triangles are congruent. And then I can say 2 is congruent to 1 by corresponding parts. And then I can use that converse to say they're parallel. Now let's do this step by step. First, I want to prove that this triangle is congruent to that triangle. What step do I need to prove those two things are congruent? I need a third piece. I have a side. I need a third piece to show that they are congruent. Brendan, I haven't heard from you yet.
ZX is congruent to ZX.
Yeah, ZX is congruent to ZX. And that is by reflexive property. All right, our goal is to prove that those two triangles are congruent. What's the next property that lets me say those two triangles are congruent? You can either do the whole thing and name the triangles, or you can just tell me that property that we're going to use to prove that the two triangles are congruent. Who haven't I heard from? Ishana? I think I heard from you, but Ishana. Side angles. Do I know an angle yet?
You know 1 and 2 are congruent.
We don't know that. That's only if they're parallel. We're working backwards. We don't know they're parallel. We were given this side is congruent to that side. We were given that side is congruent to that side. And Brendan made me say that this is congruent to that. So how many sides do we have? 3. Don't we have a theorem that says if I know all 3 sides, we're good to postulate? Which one says those 2 triangles are congruent? Side, side, side. Yeah, we are using side, side, side. Our step 3 would just be side, side, side. I have all 3 sides of each triangle being congruent. Now we just need to name it. So I'm going to name it triangle WZX is congruent to triangle YXZ. Did I name that correctly? Did I name it correctly? Cece?
No.
No?
Should be X, Y, Z.
XYZ? Let me double check my way. So I have WZX. W to Z goes across 2. Z to X goes across 3. So that's go from 2 to 3. Mine goes from Y to X, which is 2 to 3. Mine's actually correct. Mine is actually correct. Yeah.
Would CWX is congruent to XYZ work?
Yes. Remember, your first triangle can be different than mine, but if it's the same, it has to be the same second triangle. All right, by side, side, side. Now we can say that those 2 angles are congruent. We can now say angle 1 is congruent to angle 2 by CPCTC. And our step 5 is I prove those 2 angles are congruent because they're alternate interior. And if alternate interior angles are congruent, lines are parallel. Remember, we're going that direction with this when we're proving it's parallel. So if alternate interior angles are congruent, then lines are parallel, so we can jump to our parallel. WX is parallel to ZY. And that is our alternate interior angles converse. All right, questions for me. These proofs don't get easier. The only way they get easier is if you work them and understand them. If while working on them you don't understand them, that's a good time to come see me before, after school, find me in a free period or at lunch, and ask me questions on how to do it. Now is the time to get this down. We are fresh. We are just starting these proofs off. Now is the time to have a strong base. Don't wait until 2 days before the test and say, I don't know how to do the proofs at all. All right, that's almost too late. You're going to struggle still. Yeah.
Can you explain why angle 1 and angle 2 are congruent?
Yeah. So we proved that this bottom triangle and this top triangle were congruent. Well, as soon as the triangles are congruent, all their parts are congruent. So 2 has to be congruent to 1 because the triangles are congruent. Just like 4 and 3 would be congruent, W and Y would also be congruent. All the parts need to be congruent between the 2 triangles.
Well, why would 2 be corresponding to 1 and not say corresponding to angle 3?
Because that's how we named it correctly. We used the sides to name it. So I said WZX and YXZ. So all those particular angles must match up to each other. So Z in one of them must match up with X of the other one. And Z is up here, X is down here. So these are our 2 corresponding. You have to be very careful when naming it because that's going to let you know which ones are congruent. Okay? And I did name it correctly. Grant, did you have a question?
No.
No? Okay. Other questions for me?